Hello everyone, welcome back to the channel. We are halfway through in our core module. Now let's define the database. So it's going to be a Kotlin class. I'm going to call it Pocket Goods Database, an abstract class. It has to inherit from room database. Annotate this with database. Version is going to be 1. Export schema, say false. Entities. So user entity, product entity, image entity, wish lists, and app settings entity. And we need to add a type converter. It's going to be controlled converter. So we need to convert from timestamp to date and vice versa. If you are not familiar with the converters, I highly suggest my old tutorial. In parameter, we need to provide JSON objects. Annotate this with provided type converter. First direction. So from timestamp, it's going to take into a parameter long and it has to give us a date, value of lit. Now let's the other way or the other direction. It is date to timestamp. So we'll return date and timestamp. Type converters, all we have to do right now is to define our DAOs. So basically we're going to use the user DAO, product DAO, wishlist, and app settings and images. So let's create first of all the DAOs and we're going to add them here because it's going to be the last step. Let's do, for example, the app settings DAO. It's annotated with DAO. We have to add a method that's going to save the app settings. So it's going to be a suspending function. We need to provide an entity, insert, and on conflicts strategy, it's going to be replaced. And get app settings, get everything from app settings table and limit 1. It has to be a flow because we need to have a real update or real-time update. Next one, it is for image DAO. Again, it's going to be annotated with DAO. And the first method is going to be insert image. So it's going to be suspending function. I think it's the suggestion is correct. Suspending function, delete image. So that's pretty much it. Let's go to the other DAO, which is for the product. Annotate it with DAO. We have to insert a product. It's going to take the product entity and it's going to replace the old one. Get the product detail or the cached product. It's a good idea to annotate this with the transaction because we are dealing with nested relationship. And keep in mind, whenever you are dealing with nested relationships, it's memory consuming. So you have just to take this into consideration. So select everything from product table where the ID equal product ID that we're going to provide here. It's going to return a flow product with images as a parameter. The product's ID, the last function is going to be to delete all the records. Now let's implement the user DAO, or let's define the user DAO. First one is going to be to insert user. Now let's get the cached user with the wish list. It's going to return a nested relationship, which is user with wish list and products and images. Now let's delete all users. Whenever we want to, for example, log out the user, going to delete all users. If we want to refresh the old data or the old cache with a new one. So delete from users table, of course. And here we have to do where user ID equal ID and user ID has to belong. I'm going to call it here clear. So that's pretty much it for user DAO. Let's go to the last one, which is for the wishlist DAO. I'm going to insert. Let's get the wishlist. User ID equal user ID. We'll define this later on. Flow of list of wishlist item entity. Delete wishlist where the products ID equal products ID and user ID equal user ID. And it's going to be a suspending function, delete wishlist item. And the other one to clear all the wishlists. So delete from wishlist ID where user ID. And we have provided here the wishlist or user ID. Now let's add those DAOs to the database. Abstract function, user DAO, app settings DAO, product DAO, image DAO, wishlist DAO. That's about it for the definition of our database. So we are done with everything that has to do with local caching. So if you do remember some of my oldest tutorials for Kotlin and the Jetpack Compose, I have defined a helper function for navigation. So basically what it does, it's going to execute a block of code or a code before navigating. So in order not to repeat the same pattern, I created a extension function over host controller. I'm going to call it navigate, callback function before navigate. So there's no need for this parameter. And nav options, call here on before navigate, and we do navigate routes and nav options. In the first part of the tutorial, we have defined string avatar, an extension function on string. It's going to take the first letter of the first name and the first letter of the last name, and it's going to be considered as a string avatar. So we're going to trim first of all this string. So we're going to call it trim without using this, because this refers to the current string that we are working on. So this is repetitive, so I'm not going to do this. So it's going to be directly trim, and we will split by this regex space to regex. We will return check first of all if the size is more than 2 characters. We can do, for example, a word and space a word and space another word, so 3 words. In this case, what we will do, so I'm gonna do $, for example, put the first element, because we are sure that the first element exists, first or null. It's going to give us the first character to uppercase. Otherwise, because this is a nullable instruction or nullable value, it's going to give us empty string. Second part, it will be, let's say, the second word, and uppercase, empty string in case we don't have the element. In case we have only one word, I'm going to take 2 characters, uppercase. By default, it's going to be empty string. I'm going to add here in the util package a class for validation purposes, validator. It's going to be an open class, and all the methods are going to be wrapped in a companion object. So let's define here default password pattern for validation, at least 1 uppercase, special character, and 1 number. Add a function that's going to validate the password. So we're going to call it is valid password. As an input, it's going to take password. If you would like to add another pattern beside this one, so basically it will return pattern to regex and matches the input, which is the password. And another function that's going to validate if we have a correct email. It's going to be email dot is now empty, and patterns email address and the matcher email and matches. So I think that's pretty much it for the validator. I'm going to create here a new file or new folder, not a new folder, it's going to be a new package. It's going to be called dispatchers. A rule of thumb when it comes to dealing with dispatchers in Kotlin, you should never hardcode a dispatcher. You can get away if you are not going to test your application, but whenever you're going to do, for example, integration tests or test your view models, you should provide a test dispatcher. And in the production, you're going to use the normal dispatcher. So I'm going to create here an interface. I'm going to call it dispatcher provider. Basically, we have the main dispatcher. The main dispatcher is going to be from the coroutine, and the input-output dispatcher, default dispatcher, and unconfined dispatcher. So this is just an interface that we can implement, for example, in our test case. We have to implement this for testing, and in production, we're going to implement this in production. And we have to tailhead how to inject dispatcher provider, and we're going to see this once we are going to define our DI mechanism. So we're going to create 2 classes or 2 implementations. The first one is going to be used whenever we are not testing our application or our view model or our class, or we're not performing any test. And the other dispatcher is going to be used whenever we want to perform the test. So let's start with the default dispatchers. That's going to be used whenever we are not running any tests. Default dispatchers. So I'm not going to enter in details what is inject and how it works. It's going to inject this in constructor, has to implement dispatchers provider. So for the main dispatcher, it's going to be dispatcher or dispatchers.main, input output dispatchers, input output for the default, and for the unconfined in dispatchers. So this implementation will be used, let's say, in production. The other implementation that should be used whenever we want to test our view model, for example, hence the name test dispatchers. We need to implement the interface. First of all, I'm going to create here a local variable or local value. It's going to be called test dispatcher from the standard test dispatcher. For the main dispatcher, it's going to be test dispatcher. We're going to assign everything to test dispatcher. And we're going to show Health how to provide this dispatcher interface. We have done this approach for another reason. Basically, in our application, you're going to see when we are going to deal with end-to-end tests, we need to distinguish between what are the dependencies that has to be used in production and other dependencies that should be used whenever we perform our end-to-end test. Our test dispatchers or dispatcher provider is testable, and we can use it directly in our view model. And during the configuration, if we are running tests, we're going to use test dispatchers. And if we are running the application in device or emulator in normal environments, we're going to use default dispatchers. Now, the last thing that we have to do here in the user package, which is the API helper class that's going to handle for us requests. We have done the API service in the previous tutorial. We're going to basically do the same thing here as we have done in TypeScript. In util, I'm going to create a new package, API. The API service that will use the Ktor client. And of course, we have to make this class testable. And we have to provide here the engine. So why we are providing here the HTTP client engine? Because in this case, we need to mock the HTTP client engine. In other words, whenever we are going to test our application, we need to use the mock response or to simulate the response. In other words, we should never hit the real API endpoints. And when we are running the application in production, we can use the Ktor, the normal Ktor clients. So I'm going to create here clients. So the client, it will be from HTTP client as a parameter, the engine. We need first of all to install content negotiation. The converter is going to be JSON, pretty printing for the JSON response, serialize null, strictness lenient. I would like to add here another configuration for my clients. So I would like to show actually what is happening in the request. I'm going to install login. I'm going to define here a simple logger, if you will. At the end of the day, it's an object from logger. Override the log. Let's show, for example, Ktor, and it will be message. So level is going to be all. We have to specify here the base URL for our API calls, default request. So the API base URL is the local, whatever you're going to put inside the PHP artisan serve, and whatever you have in your local IP address, it's going to be the local IP address / API. And for the headers, by default, we're going to accept application JSON. Let's start the first one, suspending function. And again, we're going to use inline function and reified to enhance the performance of our class. So the base URL or the URL is going to be string. And we have to pass the headers if we are dealing with token, because in our case, we have to send token in order to access a private route in our API. Preferably, I want to use map, and it's going to be string and string. And let's make it optional. And this get, it's going to give us a type T. Let's create the response, or let's get the response. So the response is simply client dot get URL, the headers, and if it's not null, and for each add another header to the default headers. If the status of response is success, else we throw an exception, and it's a good idea to use the API error or a custom API exception. We will define it afterward. If in case of success, we're going to return the response and body type API response that we have to create. It's basically a DTO that we will create. So let's define the two needed classes. Let's get rid of API error. First of all, it has to inherit from the exception base class, override value message, the cause of the exception. I'm going to create here a suspending function, and it's going to be an extension suspending function on response exception. In order to access the body, let's call it to API exception. Create here the body response body as text. So API error. For the message, it will be HTTP. The code is going to be a response and status and value. Let's say, for example, if we have unauthorized from the body, it's going to show us in the message HTTP 401, and unauthorized should be from, in our case, it is from our Laravel application or Laravel API. So, and the cause exception is going to be this. Now let's define the API response. That should be a generic DTO for API. So first of all, it has to be serializable. It's going to only have one parameter or one field. It's going to be, which is data of type T. So let's come back to the API service, API response, and we can access the data. Error for the message request failed, for example, with status without value. So the possible exceptions, at least that I know of, the first one, it's going to be client request exception. So I'm going to do here to API error. In case, for example, if it throws server response exception, so the same thing. In case it's going to throw, for example, serialization exception. In this case, we will just do, for example, API error, and in the message failed to parse the response body. The default exception is going to be unexpected error. So the same thing, going to do the other function, raw get. The response is going to be like this. In case for the body, instead of API response, it should be just of type C, and we don't have data. So let's implement the post method. In our case, we need type of the body. So we have to do it in a generic manner. Whatever we're going to get as DTO, and the other one is going to be refined. And the body, we need to pass in parameter the URL, the body of type B, and the extra headers if we would like to attach the GWT token. Instead of get, it's going to be post. The content type, it's going to be headers, and get content type. Otherwise, it will be content application JSON and to string. Now we have to set the content type and parse the content type that we have defined previously. We need first of all to test if the content type does contain form URL encoded. Otherwise, we're going to set the body as it is. Why I'm doing this, because I want my class to be reusable, not only for this project, but for other projects, if you will. You can just take this class and use this, for example, in your own projects. So if the content type equal content type and application and form URL encoded. So in this case, we have to get the parameters and build. So basically we're going to append the keys and the values into the body parameters. Body as map. So we would like to append keys. We're going to convert it to string and value to string. Form data and parameters. So otherwise, we're just going to do set body of the default body from HTTP request builder. If response is success, API service of type C dot data. If there is an error, gonna throw the same errors as we have done before. And with the same logic, gonna do raw post. And again, with the same logic as this one, we're going to define the put method. So this is basically our API service. So as I said before, I'm not going to use, we're not gonna hit real API endpoint. We need to mock our data. So this is going to be the objective of the next tutorial. I hope you liked the video. See you in the next one, and happy coding.